Okay, so the 2024 section C, question 4, part A is based off kind of a cycloid. So essentially you have this circle here, think of it as a wheel, the wheel of a bicycle or something like that, and it's rolling along this curve here that goes over as far as A. And we are asked to plot the locus, so plot the path of basically this point P on the circle as the circle rolls, so it's going to go and move up and then come back down again. So draw the given diagram. Okay, so it's fairly straightforward to set up. It's just a 60-degree line of 45, and this is a radius 130 arc, and this is a radius 27 circles. So there's nothing complicated there. It's the part 2 of the question is plot the locus of point P as the circle rolls along this arc. So what we have to do with these, right, is first of all we're going to have to plot points along the ground. Right, I'm actually just going to call this the ground and this as the wheel. So basically plot points along the ground for where different points on this circle would hit it. So what I'm going to do is I'm going to take my circle and split it into 12 parts. So this line is at 60 degrees, so I can just use my 60-30 to finish off splitting this up into 12. Now, it was just convenient that it was at 60-30. If it wasn't at 60-30, another way you can do it actually is if you just take your compass and put the radius on it. If you put it at any point on here, you can see there, if I swing it to the top one here, it swings through that point there, and vice versa, so you can split it up that way as well, but this was kind of convenient. So here's the point on the ground, right? So as the circle rolls to the right hand side, as we're told in the question, right, so it rotates this way, the first point that's going to hit the ground is going to be this one. I'm actually just going to label these. So I'm going to call this point 1, and then point 2, 3, 4. 11 and 12 is just back down to the ground again, or 0 if you want to call it 0. But the first point to hit the floor is going to be the first one here. Now, to plot those along the ground, what I'm going to do is take the distance between any two of them. Okay, so just take it from the up to the first one here, right? But they're all equal, so it makes no difference. And just mark it 12 times along the ground. So 1, 2, 3. Okay, so there's the 12th one. Right, and what I'm going to call these, I'm going to call it, use a different color. So I'm going to call this one ground 1. G2, G3, Alright, now you can call them whatever you like. I just tend to go with G for ground, and this just being the point in the circle. Alright, so I've got those, right? Now, the other thing that I'm going to have to plot is the center of the circle, which is here. So as this rolls along here, it's going to obviously move with it. Now, the radius, it's a circle, so as it rolls, the point between where the ground and the circle touch, the distance to the center of that circle isn't going to change the whole way along. So basically, this center is going to be parallel or concentric to this to the ground here, right? They're always parallel. So what I'm going to do is take my compass, use the same center point that we used to draw this arc, open it out to my center point, swing an arc there. Okay, so this is the path of my center point. Right, I'm actually going to call that C. I know the circle itself is called C in the question, but just for the sake of this, I'm just going to label that as C for center. And like I have points for the ground here, I want to get points, so I want a C1, a C2, a C3, a C4, etc. that correspond with the ground points. So what I'm going to do is draw a line from the center of my arc here through G1, like so. It hits that arc, and then I get point C1. Same here. Alright, you just repeat that from each one. You'll get all your points for your centers. Alright, now this process is the same regardless of what size the circle is, what shape the ground is that the circle is rolling on. You're going to repeat this process each time. Okay, it might be slightly different getting these C points. So for example, it could be rolling along just a flat ground, it could be rolling on the inside of the circle, but it's generally the same kind of thing. Alright, so now that I have all these, it's C2, C3, C4. And you'll notice like each number should be the same, so 4 and 4, 5 and 5, 6 and 6. They should be the same. Your numbers should be the same anyway. Now, once we've got this far, we then just have to go off and solve it. So, solving this, alright, there's kind of a formula that I stick to. Alright, there's a two-step process. I'm going to write it down here so you can kind of follow it. So you have on compass, and then swing from. It's almost like a table, right? So there's step 1 and there's step 2. So essentially what you're going to do is you're going to go step 1. What you're going to do is take from the number, right? Actually, I'm just going to match up the colors here as well. So you're going to take the number on your circle, right? So that could be 1, 2, 3, 4, 5, 6, whatever it is. You're going to take from the number to point P. And point P is that point there. And you're going to swing it from ground number. Right? So for example, if I'm doing my very first point, I'm going to take from number 1 on the circle, I'm going to take the distance from number 1 to P, that's on my compass. I'm then going to put the pin of that compass on ground number 1 and then swing an arc. I'll demonstrate in a second. Step 2 is going to be taking from C to P and then swinging that from C number. And essentially then what you'll end up with is 2 arcs that cross over each other, and that will be your first point. So I'll demonstrate that to you now. So as I said, right, I'm actually going to, I'll zoom in another small bit, just so you can see this a bit clearly. Okay, so I'm going to take from the number on the circle to point P. So that's number 1 here on the circle to point P, which is at the bottom here. Alright, so that distance, and I'm going to swing that from ground number. And the first one I'm working with is obviously point 1, so G1. I'm going to put the pin in my compass there, and I'm just going to swing an arc somewhere there. Okay, we don't know exactly where it's going to be, but if I need to swing a bigger arc, then I'll do so. Then, right, so that's step 1 done. Step 2 then is taking from C to point P, and I'm going to swing that from C number. So it's just going to take from C to P, and then I'm going to put the pin of my compass on C1 and just swing. And you can see there then, right, you end up with your 2 arcs crossing at that point. That's my first point. Right, I'll call it P1. What we do now is repeat the same process, but we'll just move to number 2. So I'm going to take from number 2, so again, the number on my circle, which is here, so number 2 to point P, which is again is still here. So I'm going to take that distance, swing it from ground number, so I'm going to swing it from G2 this time. Swing it in there. Right, now there's going to be a lot of arcs here in a second, so I suggest you do them one at a time. Then take from C to P, so C to P, which is there. Swing it from C2. And there's that point. And there we go again. You go back to step 1, so take from number 3 this time to point P. Okay, point P doesn't move. Alright, so we're just sticking with that. So from number 3 here on my circle to point P, which is that. Then swing it from ground number, so swing it from G3. Again, just keep an eye on those arcs, you know which one is which. And take second step C to P. Swing that from C3. Get your point here. Alright, now I'm just going to pause the video here. I'm going to do up as far as 0.5 and up as far as 0.6, because I'm just going to show you something different with 0.6 an issue that you might run into. Okay, so I'm up as far as 0.5 here now. So I'm going to do 0.6. Now, the problem people get with doing 0.6 is, I'll show you here now. So when you take from point P to 0.6 and you swing it from C or G6, okay, so you swing your arc like so. Then you take from C to P, C to P, and you swing that from C6, and you end up with this sort of situation where you don't have a clear point of where they actually touch. Alright, now what I want you to try and imagine in this situation, right, the solution for this is actually just to extend this line up in this case, and there's 0.6. But the reason for that is, if you can imagine, this circle has rolled across to here, and like there's C6 now, right? Point P was originally on the ground here, alright, and as it was rolling, it's moving up and up and up. What has happened now, when we've got to 0.6, is this circle has literally moved upside down. So 0.6 is now on the ground here, and point P is straight up in the air. Okay, so this is the diameter of that circle directly above it. So that's point P6. Alright, so that just gets people slightly confused and caught there on which point, and how to actually pick a point for point P6. Once you've got to that, alright, so if I actually just draw my locus for what we have so far, we have an arc. It's like a semi-ellipse almost. It's that kind of a shape. It's a freehand arc. So it's basically that. What we're going to have is we're actually just going to have the exact same shape going down the way. It's going to finish down here. This is actually going to be my last point. It's going to finish right there. But we have to repeat the same process. We have to swing our arcs and do our two-step process here again. So what we're going to do is take from point 7 to point P, swing that from G7. Okay, so a big arc up here. I'm also going to show you an issue you might run into here as well. So this here is my arc for 7. I'm going to take from C to P now, and I'm going to swing from C7. Okay, so I have a point here, but I also have a point there. Okay, you may have come across this issue with point P5 as well. Okay, so I have a potential point here and a potential point there, and it's a question now of which one do I choose. Alright, generally when this happens, alright, you can usually kind of look and imagine if this is a circle rolling along this line. Okay, you have to imagine like if there's a point on this here, we'll just say it's that, and that was rolling along here. Sorry, if it started here originally and rolled upside down to that position, it's not going to miraculously just take a dive back in the inside. It's going to kind of follow that curve. You can see, even if as I roll along the T-square here, for example, okay, you can see it's going to travel up, and it's not going to just start suddenly diving back down inside it. It's going to continue the same kind of path that it was originally on. So that would make this one wrong. Okay, it is actually in fact this one. Alright, but if you can't imagine that, generally I choose the one that is going in the direction that's furthest to the direction that you're traveling in. Alright, so we're moving to the right hand side here. Alright, when we were originally coming up here, okay, we could have ended up with a P5 that was in here somewhere, but that would have been too close to 6. Alright, so you just kind of have to use your kind of common sense there. So point P7 is here. So I generally pick the one that's furthest away in the direction that you're traveling. Now, point 8, okay, so 8 to P, swing from G8. Okay, you kind of get used to this the more you do them. And C to P, swing from C8. It also helps as well time-wise if you have 2 compasses in the exam, because you can just set one as C to P and then just you only have to change one compass. Alright, so even a kind of a compass from a mat set can just be handy and will do for this kind of thing. And yeah, it just kind of saves you a small bit of time. I'm just going to finish it off quickly. There's 11. Alright, so there are all the points. Again, freehand arc down for the side. And that's it. Alright, and it finishes back down here at 12. So if you can imagine, it started down here at 12, rolled all the way around, and it landed back down to the ground at 12. So that's your last point. Right, that's that question done there.